If you deposit $5,000 into an account earning 4% interest that's compounded continuously, we have two questions for you. How much money will you have in 10 years, and how long will it take to double your money? So what is the first thing we notice here? The 5,000. What's this piece going to be? Yeah, that will be our initial amount, the amount in our account, our principal. What else we got?
The percentage.
The percentage. What is this as a decimal? 0.04, and that's going to be our rate. What else do we need to have here? Well, one more piece we need. What equation are we putting this into? What kind of equation are we going to put this into? What's it going to look like?
5,000 plus 1 plus 0.04.
Super close. Super close. Watch out for this guy.
Oh.
The compounded continually means we're going to use which equation?
The
PERT. That's going to be, my pen's are being grumpy, guys. PE to the RT. So this guy. So the amount we have left in our account is going to be our 5,000 E to the 0.04 T. E is a number on the It's a button on the calculator. T is our time that we don't have yet. A is the amount in the account that we're looking for. So if you set this up and just use the wrong equation, your answers should be very, very similar. They're just going to be slightly off. It would get you a majority of the points on it. Like, totally cool. It's still doing the right things. It's just starting from the wrong place. So if we want to know how much money we're going to have in 10 years, where is this 10 going to go in our equation? T. So we're trying to figure out how much money we have in 10 years. So that's going to be our A equals 5,000 E to the 0.04 times 10. This is very much a last chapter thing. So all we got to do is type this sucker in the calculator. So we can do that. I'm going to put my calculator up in front of the screen. If I can find my mouse, there it is. So we can type this in the calculator with our 5,000. To get E, that's when we hit our green button and then the ln button. That gives us E and kicks us up into the exponent. We put in our 0.04 times 10. You can do that operation. You could put it in. It's just 0.4. But we can put it in just exactly like that. And it gives us $7,459.12. So the amount we would have in 10 years is $7,459.12. So that is very much like how we did it last chapter. Part B is very much this chapter situation. When they're asking how long to double our money, what are we going to do? How are we going to set that up? How much did we start with?
5,000.
So what are we looking for? 10,000. So we want to know when the amount in our account, when our total is that $10,000. Double the money we started with. So the rest of the equation is going to stay the same as this guy here. So it's starting from scratch is what it feels like. 5,000 E to the 0.04 times T. And we're trying to figure out what T is. That's the guy we want to know. We want to know what T equals. So what do we do to try and figure out what T equals?
Are you trying to get the E by itself?
We will need to get the E by itself first, yes. How are we going to get the E by itself first? Super close. Divide by the 5,000 because they're currently being multiplied. So to get rid of that 5,000, I need to divide. Whatever I do to one side, I do to the other. So we're going to divide by 5,000. I'm going to zoom in a bit just because it's getting really hard to read my handwriting because I'm writing tiny. So that's going to give us 10,000 divided by 5,000 actually gives us 2 equals e to the 0.04 t. What can we do from here? Not tax evasion. Put it in log form. Tax evasion's a clever thought, though. Illegal, but clever idea.
It's only illegal if you don't. It's only illegal if you get caught.
There's only punishments if you get caught. It is illegal whether someone sees you or not. The legality does not change based on observation. Just like speeding is illegal whether you're caught or not. So log base what? What's our base? The e, good. Log base e of our argument, that's the 2. It's going to equal our power, the 0.04t. That BPA log BAP, that is a super duper important piece of this chapter, and it comes up very frequently. So our log base b of a equals p, and our BP equals a. These two pieces, I'm going to be writing that a, that we can switch back and forth between them are a super duper important piece of this chapter. So if that's a place where we struggle, lock in on that today because like we need to know that for the chapter test. BPA log BAP. It is really, really, really important. So log base E is all super duper wonderful, but there is an easier way to write log base E. ln. So this is ln of 2 equals our 0.04t. We like this because ln's a button on the calculator and we don't have to use a change of base for anything. Huzzah. We love that. ln of 2 is a number. A gross number, but a number. We're still trying to get t by itself. I want to know what t is. What can I do to get t by itself? Yes. We are going to need to divide by our 0.04. Because I want this to go away from the t. But whatever we do to one side, we do to the other, and we get 0.04 over here. So technically, we have an answer. I know ln of 2 divided by 0.04 equals t. Huzzah! We have an answer. Yay! How many years is that? You gotta type it in the calculator. Yay! It was probably like an aloe or a bird dog. What's up? Yeah, give me just one second. Let me finish this one. So let's type this in the calculator real quick to get our decimally answer. So we can go into our calculator and on our second column, third button down, we get our fraction. We can put in our ln of 2. And we're dividing that by our 0.04. And we'll go ahead and just take one decimal place on this one. So it's going to be 17.3 years. So if I wanted to double my money and get up to $10,000, it would take 17.3 years. Okay. Zoom it out just a smidge so you can see both things. Questions on this one? Okay, so what the plan is for today is I am perfectly willing to work through absolutely any question you guys have on the review. We've got a chapter test coming up tomorrow. So what do you want to look at?
Maybe we should give them the review Friday.
I think so. I was gonna say that up in the folder up there, the very back one in the homeworks, the kind of purple one. Yep, that one. I think there's also a blank copy of it on the Canvas page, but I'm not entirely sure. Number 12. Let's see where that one is. Last page. Ah, describing the transformations. Sweet. So looking at number 12 up here, that's thinking about our transformation form, our kind of graphing stuff, where we have our kind of structure. That's our f of x is our a log base b x minus h plus k. That's where we get our a, h, and k from to do our graphs, to take the, x plus h, y, a plus k, because graphing makes us yuck, all that jazz. So what we're going to do is we're going to start just kind of playing match 'em up here. So looking at this first one here, what do we see? What can we match up? What is the a in this first one? What number is multiplied out in front on part A? 1/3. So with our a being 1/3, what does that do? What does an a of 1/3 do? It is so little and cute. It compresses because it's so little and cute. I want to squish it. So it's going to look like somebody kind of sat on it. So this means we are going to have compression. Compressed. Because it's not bigger than 1, correct. If it is smaller than 1, it's compressed. If it's bigger than 1, that's when we're big kid yoga and we stretch. If it's negative, that's when we get the flip where it's reflected over. So A has a couple of jobs it can do. It'll do its reflection or it'll do stretch compress. What else do we have up here we can match up? The x minus 1 is going to go with my x minus h. So what is my h? 1. What does h tell us is going to happen? That is the ultimate question. You've given all 4 possible options. So what is an h does what? It's going to go side to side. H's are horizontal. So think about it. Think like our number line up there. If I go from 0, which is where we start, to a positive 1, which way do I go? To the right. If h is positive, it goes to the right. So this is going to go right 1. The only time that sign changes is if we're looking at this whole sentence here, because I know we're kind of stuck on that. X minus 1 gives us an h of positive 1. Since this has a minus here in the statement, we just look at this number. So just as a quick pop down, on the next one, what would our h be if we have x plus 10? What's our h on this one? Negative 10. Good. And that means it's going to go which way? Left. So just tucking that in there so we could practice that h because we got a little bit stuck on that one. We have one more transformation on the first one on A. What else we got up here? Look at the top one. That's the one up here. The 14. The 14 goes with our k. What transformation does k give us? Up. Yep, that's going to go up 14. The 7, the B, is not a transformation. That is our starting place. So don't tell me that 7 does something. It's what we start from. That gives us our parent. The B is not a transformation. The B is our starting place. So those are our transformations. A, H, and K are our transformations. That B does not do a transformation. So let's look at part B just because we got a little stucky on it. We already did our H of minus 10. What are our other pieces we've got?
The negative 4.
The -4 is which one?
The A.
A. So our A is -4. What is our transformation with that? What does that tell us happens? Think about the negative and the number itself separately. What does the negative do? I was going to say it's not going to make it get smaller. It's going to make it flip. Think about parabolas. When we had our happy face parabola versus our frowny face parabola, we had our positive A's. Everything was up and happy and smiles. If it's down, it's frowny face because we have bad news. So the negative sign makes it reflect. It's going to go upside down. It's going to flip. I'm totally cool if you say flip as well. Then think about that 4. Is the 4 bigger than 1 or smaller than 1? Bigger. So what's that going to be? If it's bigger, what do we call that? Stretch. So think about the sign and the number separately. Stretch. So that was for our number 4 here. And then what's our other transformation on this guy? The -9. What's that going to do? Down 9. Okay, so now that we have found those pieces, let's finish out these last 2 questions on each of these. So for part A, I kind of answered that for us. Our base, that B, is this 7. That gives us our starting point. Our asymptote here, when we're thinking about these and we're graphing them, we're going to have a vertical asymptote at one point where it gives us kind of this wall that we can't crash through, right? Which of those numbers for part A is going to be our asymptote? The 1/3, the 1, or the 14? Bless you. If I have a vertical asymptote, if I move up 14, does it change my asymptote, or am I just kind of sliding along it? I just kind of slide it along if I go up and down, right? It's our horizontal shift that would move our asymptote. So it's going to be our H every single time. It's always going to be x equals H for our asymptote here. Our vertical asymptote is always going to be at x equals H. So in this case, it's x equals 1. So for part B, let's answer those same questions. What is our base for part B?
Um,
11. It's that guy down here. It's the thing where you're going to use to get us started on graphing. And what is our asymptote going to be on this one? X equals, careful, careful, -10. Because we took our whole graph and picked it up and scooched it 10 spots that way. So that means our asymptote's now over here instead of being on our 0. So we scooch it left. Our H moves our asymptote. Okay. Put questions on that one. What else do you want to do? 13. Oh, kind of our expanding, condensing stuff. So this is just trying to get us to look at our expanding, condensing in a little bit of a different way. Thinking about it in terms of somebody doing the problem. So everybody here did something. And they all got the same exact answer. And we're trying to figure out why. So we're given 3 different problems, and we wound up with the same answer. How can I make Maya's, this one, just going to zoom in on it. How can I make this one look more like this? What did she do? what these are all looking at is these are all looking at our condensing stuff where we take our powers and turn the, or our coefficients into powers, because I'm going the wrong way. Coefficients go into powers. Our addition turns into multiplication, and our subtraction turns into division. So we're using our condensing properties here. So Maya's first step would have been to take her coefficient that we have of this 2 and put it as a power on that argument right there. So her first step should have been log base 5 of 3 plus log base 5 of 2 squared. Using our powers into coefficients. Was the what in regards to what I just did? As I heard a what. So this is our condensing properties where our coefficients go up and become powers. So I took this 2 up as a power. What is 2 squared? 4. So we can do that. Like, we can simplify that. That's one of the benefits of doing this. Because then our next step is going to be to take our addition and turn it into multiplication. So we want to take our log base 5 and multiply these two arguments. So we're going to have our 3 times our 2 squared, or 3 times 4. Well, what is 3 times 4? 12. So she did the right thing. Her answer is correct. Log base 5 of 12 is the exact same thing as log base 5 of 3 plus 2 log base 5 of 2. If we wanted to get a decimal for her answer, because that's what part B is asking us here, how could we put this guy into the calculator? Because our yellow calculators don't have the option to put in a weird base like that. So if we want to be able to find the solution, how would we put it in the calculator? So this was our condensing. This guy's going to be our change of base, where we put either common log of our argument over common log of our base, or you can do it with the natural log. Either way. I mean, technically you can do this with any base, but doing it with something other than log or ln is going to make your life harder rather than easier. So let's do something that's not awful. So to get our decimally answer, we're going to have to put it in the calculator as log of our argument, the 12, over log of our base, 5. So this is using our change of base. So this is kind of mushing things together. So this is what we will write into the calculator to get our answer for part C. For the rest of this first part A, I'd want you to look through here and see all these steps. Condense these guys down. Make sure they did the right thing. And this is asking you to think about it. How they all got to the same answer. Why does this happen? It's very much like if we think about 2 plus 2. That's a different setup than 2 times 2, which is a very different setup than 2 squared. But all 3 of those problems just equal 4. 2 plus 2 equals 4, 2 times 2 equals 4, 2 squared equals 4. So these are 3 different problems, just all wind up with the same kind of gross, kind of decimally answer. So that's what part A is looking at. For part C, we just type the sucker in the calculator, and we're going to round to the nearest thousandth, 3 decimal places. So let's type it in the calculator. Boop. We're going to have our fraction, and we can put log of 12 over log of 5. Or you can do it with ln. Genuinely, it does not matter. You will 100% get exactly the same answer for both. Those decimals are 100% identical. So we're going to take it to the nearest 3 decimal places because we were told to go to the thousandths. So here's where we're going to look at it. Is this 9 going to make us round up to 1.544, or are we going to stay at 1.543? 44. So our decimal answer here is going to be that 1.544. So I encourage you to go through and condense these the rest of the way to make sure this does work. And A is just wanting you to think about how that happens. What else do you guys want to look at? Three. So I'm on the right page. 3. The without a calculator ones. So when it says to evaluate without a calculator, I am not going to come through and yank anybody's calculators out of your hands on the test. I'm just trying to get just to see you don't have to use your calculator for these. I would 100% rather you change a base formula, type this sucker in a calculator, than leave it blank. Totally valid. But you don't need to use the calculator with this as long as we remember our BPA that switches with log base B of A equals P. Thank you, dear. So this is a really important piece here because what we can do is we can take our base and put it as the base, our power as the power, and it's set to equal the argument, these pieces. So on something like this first one, we have a base of 9 and an argument of 1 over 81. So what we're really asking you here is 9 to what power? We don't have an exponent there. We don't know what this equals. That's what we're trying to find. Is going to equal 1 over 81. I know it's a little bit of a tricky one as to start here. What relationship does 9 have to 81? 9 to what power is 81? Ignore the fraction for right now. 2. So 9 squared is 81. We love that. But how do I make a fraction flip? What? If the power is negative, it's going to flip as a fraction. So we know that 9 squared gives us 81. So that means 9 to the minus 2 gives us 1 over 81. And you can do that in the calculator as well to double check that. 9 to the power of minus 2, it's going to spit out 1 over 81. Now, if that's not something we could spot, you could always come through here and do like a guess and check situation where we go, well, 9 to the first is 9. And 9 squared, oh, that's 81. I am going in the wrong direction, so we need to go smaller. So 9 to the 0, well, that's going to equal 1. How about 9 to the minus 1? Keep getting smaller. Well, now I'm starting to see the fraction, and you can kind of guess and check your way through it. I'd rather us not guess and check our way through it. I'd be able to do it properly. But I would rather us either calculator or guess and check it than leave something blank. Your other option on these is if we don't spot this, use the change of base and type it in the calculator, just like we did on that last one where we had our log of 12 over log of 5, or whatever it was, decimal wise. You could do log of 1 over 81 over log of 9. ln of 1 over 81 over ln of 9 will also work, and it'll spit out the right answer. On something like part D, right below it, it looks a little tricksy because ln already has a base in it. ln is the same thing as having log base e. So this is saying log base e of e. So we have a base e. We're trying to figure out the power when it's going to equal e. What power do we have on something to keep it the same? 1. What if we did for part E, very similar? We have a base of 7. We're trying to find the power that's going to make it equal 1. What power can I put on something to make it turn into a 1? A 0. So anytime we have an argument of 1, it's going to equal 0. So this guy equals 0. Now actually we'll do C first as well because that guy also equals 0 because we have an argument of 1. So the last two are very straightforward. They're very much like A, where our base to some power is going to equal our argument. And we can figure those out. So I want you to try those ones. What else would we like to look at? We've got about 9 more minutes. 7. Let's look at 7. So this one's very much change of base. So we've looked at a couple like this already. So finding which ones work. So we have 5 to the y equals 9, and they're trying to solve this. So first thing we need to do on this is to switch this into log form, because we have a power as an exponent here. So what is our log form for this guy? Log base what? 5. With the argument 9 equals the y. So we've got a log form here, but none of those options below fit. These are all looking at it change of base style. So when we're looking at our change of base, I'm going to write that down here. C-O-B. That's when we have... What the heck was that? I don't have any Teams things happening. Go away. Silly, pesky computer. That's when we're going to have our log of our argument over log of our base. Or we can do ln of our argument over ln of our base. So what's our argument again? The 9. So we can do our log of 9 over our base log of 5. So that's one of the options up here. This guy is C. That guy right there. Log of 9 over log of 5. Which other one of these is going to work? A, B, D, E, F, G, or H? A. That's if I just swapped my logs out for ln. So these guys both work. The rest of them do not. To get the value of y, we type that sucker in the calculator. And it does not matter which one you do, whether it's the blue one or the pink one. Doesn't matter. ln of 9 over ln of 5 or log of 9 over log of 5.
On the e-learning quiz, it had one that was in the parentheses that could work. I was confused.
That would be if it was more like this guy over here, where we had the pieces that could combine together. So like if I look at Eduardo's over here, when we have this subtraction turns into division. So I'm going to do my powers first. So we're going to have our log 5 of 96 minus log 5 of 2 to the 3rd. So we could do this, if I condense this down, log 5, 96 over 2 to the 3rd, which is 8. So I can simplify within the log, totally fine. I can condense things down, absolutely valid. On change of base, that was over here. Nope. There it is. On these ones, this is changing our problem entirely. We have to have both ln's on top and bottom. If we are condensing it's giving us pieces inside here. This is change of base. So it's two different kind of ways of looking at it. And for our final answer here, you can type it in the calculator. We've done it a couple of times today. Okay. We've got 5 minutes. Anyone want to pick a last one? Or if you just want to have 5 minutes to work on stuff, that's totally cool.
Can I get 6?
6. The graph. All right. We will do our best to get through it. I don't know we're going to get all the way through it in 4 minutes, but we will do our best. So I'm just covering those up because I don't like those tables. So our first thing we're asked to do is we're asked to graph our parent function. Log base 3 of x. In order to get my table for log base 3 of x, what table do we need to make first? The 3 to the x, because we need its inverse. That's why a lot of the times it has these kinds of questions really nearby where it's asking the inverse, is that's giving us our parent function for the graph. 3 to the x is our first table we're going to draw. We're not going to graph it, but this is something we're much more familiar with because we pick our x's to give that good view of the middle. -2, -1, 0, 1, and 2. Our y we're getting from 3 to the x. So 3 to the power of -2 is 1/9. 3 to the power of -1 is 1/3. 3 to the 0 is 1. 3 and 9. We use that to make our log base 3 because they are inverses of each other. So everything that was an x becomes a y. Everything that was a y becomes our x. So we'll have our 1/9, 1/3, 1, 3, and 9, -2, -1, 0, 1, and 2. On our parent function, our asymptotes are our x and y intercepts. So we just have to plot up these points. So we're going to have our 1/9 -2 gives us a point right there. 1/3 -1 is a point right here. 1, 0, 3, 1, and 9, 2. It looks kind of like this. We have an asymptote right on our y-axis, so I cannot crash through it. But our parent function kind of looks like this. This is what we start with. To get our transformed function, again, I'm just trying to fly through this so we can get all the way to an answer here. That's when we find our transformations, just like we did in the earlier question, finding our a, h, and k. So our a is 1. Our h is what? What's our h? Careful. -4. Good. This is going to go left. And our k is that 1. So we're going to go left 4, up 1. And to get our table, we have our x plus our h and our y times a plus k. So that's where we're getting these pieces from. Our asymptotes happening at that x equals h, x equals -4, and so on from there. Okay, the full graph, everything up there with all the work is posted on the answer key, which is posted on Canvas. If you're working on stuff and you have any questions further on later on the day, please feel free to send me a message, Canvas, Parents Grow, email, whatever you got. I'm available. Or you can come back during fifth period during the study time for my sports hours today. Oh, snap. What?